Alright champions, we're getting there. I've removed all the pots from the front panel. I've replaced 2 of them. You can see them there, 2 Burns pots. I've rejigged the little ground bus there so it's a bit neater. I've replaced the resistors in the speed setting for the Vive Trem control. We've run some new caps there. I've reused the caps that didn't have any cracking on the casing and that weren't in high voltage differential positions. I've cleaned up the wiring a little bit so far. It's still a work in progress. There's quite a bit to do still. I spotted this little bugger. It's got the mark of the beast, the SM down there, so that's a generic silver mica. That's likely to give problems in the near future, so I'm going to replace that. There she is. If you see SM on a silver mica cap, just check it for leakage at least, but if you've got the time or if it's your amp, maybe replace it just for future's sake. Pretty much all the components which I've reworked or moved or just flowed their solder, they've had the old leads of the old component left in place, so I've had to remove them from all the eyelets as well. It's just a big joint by joint, just going over every single eyelet. That's what makes these restoration jobs very time consuming. One thing I have noticed almost everywhere where it looks like components have been replaced, it is broken off eyelets. So these are very delicate. You try not to bend them. Oh, there's the new, if you can see there, CDM cap. I just went with another silver mica. Yeah, a lot of the places where components are replaced, the tags have broken off. They're very delicate. You don't want to bend them at all. There's another example down there. They've obviously replaced that bypass cap. And yeah, no eyelet to speak of there anymore. Now, one thing I did notice, I actually removed all of these pots and cleaned the chassis and down in as much as I could into that corner as well, across the bottom. I didn't notice this before, but something dramatic has happened to that previous power switch. You can see she's flamed up real good, and there's residue left on the aluminium there. So yeah, that switch being replaced, it's definitely not original, and all hell break loose in this area at some point in its past. Alright, aside from reconstructing and reinstalling the top boost module, I think I'm pretty well done over this side. There will be likely some fine tuning required once we can power it up, but the bulk of the rework has been done, and just thorough inspection and reflowing, that kind of thing, cleaning up flux and excess solder blobs, replacing melted wires, you name it. So we'll move on to the output and power supply section and do the work down there. Alright, so I've removed the existing tag strip. I've put a new one in its place, which is the same configuration, but it has holes through the actual phenolic board there, so we can run it in one extra pretty fat wire, and the eyelets are just larger, as well as it's just a bit more sturdy. This one was starting to flex around a bit because the riveting had lost a bit of its tension. So that will allow us to, here's the heater lines coming from the transformer, that will allow us to have those as the main heater feeds, but we'll also run some resistors on the top so they're easily replaceable should there ever be a problem with a HT to heater short. The fusible resistors will be replaceable without disturbing the wiring, and we'll still be able to use that hole in the center there for the center tap for the other windings. And this is sort of almost like a fender like wax on the chassis or something. It feels harder than wax. Not sure what it is, but it's not a real good way to ground this thing. So the previous one just had the tag strip against the chassis, whatever that film of crap is in between, and then the lock washer was on top. You can see little tooth marks there on the screw hole. So I'm going to clean this up to like bare metal, or bare zinc anyway, whatever the coating is. Not going to go straight back to steel, and that way that will allow a good electrical contact, because that's your main ground to the chassis for your transformer center taps. So alright, so we've got the dropper for the first preamp node, I guess the phase inverter node there, and it's just snapped off as soon as I touched it. So every connection in this thing like every third, fourth connection, particularly ones that have been modified, they just snap off as soon as you touch them. So that's kind of what makes restoring a vintage amp so time consuming. People say, what did you do? You didn't do anything. Well, yeah, but every second wire I touched snapped off, or it was, you know, had a big blob of solder on it like that, inexplicably. I mean, you've got 2 wires going to that eyelet. Like, why is there such a massive blob and old wires and stuff left behind? So that's what you're dealing with vintage amp restorations. It looks like you haven't really done much, but like even like what's this schmoo all over the wiring? I'll unbraid them and clean that, and then rebraid them and reconnect them. I've reconnected every single connection to that. Well, not yet, but you know, redoing all the connections. That's got that strange green corrosion leaking out of the jacket, so I'm gonna have to strip that back a little bit and clean it with some alcohol before soldering it. There's just a lot of stuff like that in these amps that requires attention. Otherwise you're shaking hands with danger. Well, not danger, but unreliability. Unreliability, is that even a word? Lack of reliability? I don't know, my brain fog. Alright, so I was just examining the wiring around the output valve sockets, and I moved a couple and the jacket just fell off. Little hardened chunks there. It's just like, it's all cracked and heat affected, and it's no longer plastic. It's going back to its elemental form. And of course, same thing on the heater wiring, which is what I'm really worried about, because if they short to each other, ooh, it's going to be a bit of a light show and could put the power transformer at risk. So it looks like we're replacing all the wiring on the output sockets. Yay! What did I say about vintage amps? How it looks like you've done nothing to them, but you've spent days on them? Well, this is that. So maybe don't be so quick to jump down the throat of a tech that's charged a significant amount for something that doesn't look like it's any different, because it probably is very different. So here's some of the heater wire I've removed. Single core, very heavy gauge, but as you bend it, the jacket just comes off, crumbles. So having that happen between the 2 conductors is not something you want to happen. That was one of the not so bad bits. You can see it's sort of cooked on the ends. That's where it's real brittle. While we're reworking this area, it would make sense to move this cap further away from that hot valve. Since the terminals are right there and there, I'm not sure why you'd mount it that way. Why wouldn't you just mount it out this way with its leads going directly without any folds to the area that the eyelets that are required? So I'm going to move it over here where it's a bit cooler. That's also an 85-degree cap in the hottest area of the amp. So I'm going to replace that with a 105-degree cap, long life. Mount it over here, silicon it to the chassis, run the lead straight here, less chance of any fracturing of the component leads as well. Now to do that, I'm going to lift this resistor. It's going to come up this way. A bit hard to tell from this photo, but that's down below this level of the eyelet there. So I'll make that vertically come up, go across the eyelets, and that will give us room for the leads of the cap to come out this way. Alright, so I've removed pretty much everything that needs replacement and or reworking, and you can see over here there's something's gone bang here before, probably the bypass cap, likely in the past due to a shorted EL84 possibly. So we'll see if we can remove that, but that looks pretty cooked on, whatever this weird coating on the chassis is. But in the meantime, I'll clean those sockets and with some isopropyl alcohol and prep the eyelets, the terminals for rewiring. Sorry, I'm finding it really hard to speak today. My brain's just not working properly. Like even worse than usual. And just a quick tech tip, champions. If you ever install a new mercury magnetics transformer in an amp, the fly leads off them are Teflon coated. So when you cut off the excess, don't throw them out. Hang on to them in a little bag, and it's really high quality wire whose jacket won't melt during rework. So there you go, take that one to the bank. Alright, champions, that's pretty much the power supply and power amplifier section sorted. Many hours later, we've redone all the heater wiring as shown before. New screen grid resistors, they pretty much just go directly from point to point now. We don't worry about the orthogonal bloody right angle bullshit where we've got to add length to the leads just to make it look pretty and like a high watt. I've moved this bypass cap, got a new V-shape 105 degrees Celsius one away from the heat generating area of these valves, which was enough to cook the wiring essentially and make it so the jackets all turn to dust. So all of this is new Teflon wiring down near the valve sockets, even the plate linking wires for the two pairs. The wiring from the transformer there, we managed to clean up with a bit of alcohol. It's still okay. It was pretty hard to get it to wet with solder though, because it was starting to corrode near the ends, and I couldn't really cut much more than say half an inch off, otherwise it would be too short and we'd have to splice it and it would just be another messy thing to have to deal with. Got a new reef for long life electrolytic there, 105, actually I think that's 125 degree rated from memory, and that's just mounted on the existing tag strip there and silicon to the chassis, so nice and secure. Now it's probably a bit of an overkill, but I've mounted some eyelets there to the valve socket mounting screws and put some fast acting flyback diodes there, so if this thing's ever played without a load, like it does actually have a speaker socket hanging out the back, so he does use this with other types of speakers because it is a recording studio amp. If he forgets to plug in the speakers one day when he fires it up, he won't cause a flyback event and have to replace valve sockets, because we all know that's very labour intensive. And with amps of this vintage, we really need to be mindful of protecting the output and power transformers any way we can, because you can't buy them anymore. And as mentioned in the previous video, I thought why not, we'll throw some backup diodes there on the rectifier socket just in case the rectifier ever goes short circuit. We won't deliver AC to the rest of the amp and destroy all the caps. And there's our heater balancing arrangement. Now I think we talked about heater balancing last time, but we didn't talk about heater elevation. So here I've got two fusible resistors, 100 ohm each. That forms the balance between the two sides of the heater, reducing hum. But then further reducing hum, we've got this white wire here, and that comes down and connects to the cathodes of the output valves. That's some free elevation there. We don't have to create a voltage divider or anything. Just by virtue of the current drawn across this resistor, we'll have voltage we can take advantage of to elevate the heaters. So that basically puts any heater to cathode leakage current into saturation. There's whole articles on this. I might link them. That puts it into saturation, so now instead of getting any 50 hertz hum from the AC heaters having any leakage current between the heater itself and the cathode, now it's saturated to the point where there is leakage, but it's at 0 hertz. So that is another avenue to reduce hum levels. Just added some Teflon wire there to make the screen grid distribution a little bit more logical. I've put heat shrink on all component leads. It's clear stuff, sort of looks a little bit invisible almost until you look close, but just in case anything gets moved in the future into a position where it could touch something else. Generally though, there's not enough movement, and you'd have to punch this thing to make it go down and touch that. It would be pretty obvious that there was a problem. So now this side's done, we'll flip the chassis back over. I'll just have another look at the preamp and get it ready to install the top boost assembly, and then we'll rebuild that. So that will be fun. I've removed the top boost assembly entirely. I've just decided I'm going to rebuild the whole thing and optimize it a bit. Alright, so we've stripped all the silliness from the top boost channel. Well, not all of it, because the bass pot is a log and the treble pot is a linear. They're both supposed to be log. Now, I don't know if you've seen any photos of this module removed from the amp, but the tag strip being over here doesn't make a hell of a lot of sense, because you've got a bunch of components coming off the valve socket needing to find their way over here. So it makes a little bit of a rat's nest. So what I'm going to do is mount a tag to the valve socket mounting screw, and that will allow us to directly connect some components from the valve socket straight to there. I might still leave this as for the coax to be tied to, and a grounding point there just as an extra degree of mechanical stability. But we'll install another one just to make the construction a bit neater. So looking at the overall construction of this thing, not my coffee cup, that can go over there, I'm not sure that this isn't original. I mean, you can see the punch marks, the guillotine marks there. So this was like specifically made. It wasn't just dodged up with a bench vise. And the socket's really old, and the screws are old brass things, and old pots. So I don't know if it was maybe rebuilt by the previous tech for some reason. I don't know. More questions need to be asked here, I think, because a lot of this isn't really making historical sense. Alright, so I forgot to do video of it because I've been under the pump, but here you can see the internal construction of the top boost module, showing the tag strip, the new one up the top, and the existing one to the right, which I've used for the heater feeds. I've got the wire down in the corner for the heaters as far away from the audio circuitry as I could get, and the coax and everything's strain relieved by the top tag strip. I've installed the main filter cap there to the right with some silicone, and also made sure that was the last component that I installed, so I was happy with being able to change that in the future without too much difficulty. So catch you in the next episode, champions. We'll have a listen to this thing and see how it performs.